This video shows how to use Jsim to simulate Kolkhoff and Muller-Hills data. Jsim can be downloaded from the Physiome website. Just do a Google search for Jsim. The model equations and data are available from this publicly accessible Dropbox folder. So just type that into the URL of a web browser and you'll get to these files. You can download them. 1, 2, 3, 4, 5 files, including model equations, and they're all contained in this zip file here, so you can alternatively download that and extract the files from that. You can open the model equations simply with Notepad. This will give you a view of all the equations and the parameters. So they're all set out there as a text file, exactly as they're used by the simulation software. Having downloaded the project files, we now want to open it with Jsim. Let us remind ourselves of the aim of our simulation. So this is the expression system that we're simulating. In particular, we want to look at the effect of mutations in the C1 dimer and determine values for the parameters, determine parameters relevant to the C1 mutants. So the mutations in the helix-turn helix region of the dimer have altered their ability to bind to DNA and their ability to activate transcription. C1 has two modes of action. First, C1 protein, when bound at OR3, represses transcription. It does this by preventing RNA polymerase from binding to promoter PRM. Alternatively, if C1 is bound at OR2 beside adjacently bound RNA polymerase, then it activates transcription. So C1 can either repress or activate transcription of LAC-Z. We modelled this by changing these parameters, so the activation parameter and the mutation parameter. So there's the degree of activation by wild type, and the mutants have all lost that ability and have no degree of activation. Alternatively, they have increased they may have increased binding to promoter OR3. So the degree of increase for PC1 is 15 times 0.005 to take it to 0.075 nanomolars to the -1. PC3 in particular binds very tightly to OR3 and dramatically decreases transcription. So we want to look at how we can incorporate these changes of transcription parameters in our model. Once we have opened our model, we now need to find our project file that we've downloaded from Dropbox. So we're going to open the project file. When we find it, we select it. It's comb_01.proj. We select it and open it. It drags in all the data files as well as the source file. So if we click up the top here, we can see all the model inputs. We can see this source file, so that's all the equations. If we look over at the side, we'll see that when it dragged it in, it automatically compiled it and it says terminated normally. So this is the right hand panel. Going back to the left hand panel, our next action is to select the model itself. So that's the initial page, but if we go up here to the top, and come down here, we want the run time. So I've got these two selected. Run up the top. Oh, I've already clicked it. Let's have a look what happens. So at the side here, terminated normally. Now look at the plot. So we've generated this black line curve through the data points for PC3. So again, there's IPT on this x-axis, though here it's in nanomoles rather than in molar form. So it's nanomoles rather than moles per litre. And on this axis we've got beta-galactosidase production. Now we wish to simulate the wild type data, these red circles. So we go back here. Now we need our table of values. For wild type, activation of transcription factor is 5.3, and there's no increased binding to OR3, so that's 1. So 5.3 and 1. So in these model inputs, we need this one to be 5.3, and down here 1. And go back up here, click run, and lo and behold, come across, and now we are simulating the wild type data. It's pretty good. It goes through the rising section of data points very well, and this data over here is a bit noisy, but it seems to model them really well. Now let's model PC1. Alright, so we're going to need a 1 and a 15. So we need 1 here and 15 times tighter binding, and click up the top, run. And our data curve, our simulated curve, now goes through the data points for PC1.